Okay, a nice algebraic question about function and composite functions here. 49% of candidates got this one correct. If you want to have a go at it, you can pause the video and try for yourself. So the question is, we have three functions, f of x, which is 2 to the power of 10 minus x. G of x is 2 times the square root of 2, all to the power of x. And the function h, which is both functions, it's f of x if f of x is larger or equal to g of x, and otherwise it's g of x if g of x is larger than f of x. Now let a be the number such that f of a is g of a. Determine the integral from 0 to a of h of x dx. So we have that f of a is g of a, so 2 to the power 10 minus a is 2 times the square root of 2 to the power of a, which is, well, 2 to the power of 3 over 2 times a. So we have 2 and 2 here as base, so that means that the powers have to be equal to. So 10 minus a is 3 halves of a, or 10 is 3 halves of a plus 2 halves of a, or 5 halves of a. So a is 10 times 2 over 5, or 4. So a is 4. Okay, we can then calculate f of 4 and g of 4. So f of 4 is 2 times 10 minus 4, or 2 to the 6th is 64, and 2 over 3 halves of 4 is also 2 to the 6th is also 64, so that pans out. Now, which one is the smaller? Well, we'll just take f of 2 and g of 2 because that's easy to calculate. So 2 to the power 10 minus 2 is 2 to the 8 is 265, and for g we get 2 to the 3 halves times 2, or 2 to the third is 8. So it's rather obvious that g is lower here. So between 0 and a, we can safely say that f of x will be greater than or equal to g of x. So h of x will be equal to f of x, and so h of x will be 2 to the power of 10 minus x. Okay, now that we know that, integrating, well, this thing, if we have a to the power of x and we take the derivative, that will give you a to the power of x times ln a. Now if we integrate both sides here with respect to x, obviously, yeah, the derivative and the integration, that cancels out, so we get a to the power of x, and the integral of a to the power of x times ln a dx is ln a times the integral of a to the power of x dx. So the integral of a to the power of x dx is a to the power of x divided by ln a. So now that we know that, the integral of 2 to the power of 10 minus x dx is, well, that's the same as minus the integral of 2 to the power 10 minus x of d of 10 minus x. I can just plop in a constant and a negative here, provided that I put a negative here too. So we have 2 to the power a dA, whatever. So that gives you minus 2 to the power of 10 minus x over ln 2 plus a constant. obviously. Okay, so we have to evaluate this between 0 and a, which was 4. So minus 2 to the power of 10 minus x over ln 2 between 0 and 4 gives you here min 2 to the power 10 minus 4, and then minus 2 to the power of 10. So obviously this is 6, but we can just factor out 2 to the power of 10 here, and obviously also the denominator, which leaves us with minus 2 to the power of minus 4 plus 1. Minus minus gives you plus here. So that's 2 to the power of 10 over ln 2. This is 1/16, right? Minus plus 1/16, or 2 to the power of 10 over ln 2 times 15/16. Okay, so 16 is 2 to the power of 4, and then we have power of 10 here, so that leaves us with 10 minus 4, so 15 times 2 to the power of 6 over ln 2. 2 to the power of 6 is 64. 15 is obviously 10 plus 5, so that gives us 640 plus 320, the half of it, or 960 all over ln 2, and 960 over ln 2 is answer C.